Hello everyone and welcome to today's webinar. My name is Filip Radukic and I'm a product manager and senior consultant here at CA Experts, and as such responsible for the browser-based viewing and associated technologies. Today I'll be taking on a tour of the all-new UPV browser and the UPV web services, the new host environment for the browser-based viewing technology. As always, this session will be recorded and we will provide you the link to the recording subsequently by email. At any time during the webinar, feel free to use the chat or questions panel and state your questions, and I will try to answer as many as possible after the session. Okay, this being said, what are we going to talk about today is UniversalPlantViewer in a web browser. So open even the hugest plants in a matter of seconds, and how this is done. First of all, let's look at the agenda. So we'll have a look at the general concept behind it, the new user interface and the changes that come along with that, the UPV browser and what it actually does, the functionality of preloading, how does it look on mobile devices, how is the API integration realized, and finally, what are the requirements regarding hardware and software for the system. So, talking about the general concept, what are the issues that we're facing generally? Deploying and installing software is necessary, which means some really administrative tasks that have to be done before you can actually start viewing. Not every stakeholder has adequate hardware, so this can be slow network connections, really low CPUs, low RAM, low graphics, and finally model sizes can be limited by mobile hardware because there's just different configurations for different devices available, and some of them might have limitations. So the solution would be outsource calculations to a server, meaning that the hardware of the device in use is becoming irrelevant. No plugins or specific software or hardware installations should be required to make the whole system fully independent from the client setup. And streaming graphics and human interface devices only, like mouse and keyboard inputs. And this way streamlining the data flow. How do we realize this? Let's have a look at the architecture. So basically, you can use any client on any device on any network, while the server setup is or consists of basically between 2 and 3 components. So one component is the UPV web services that actually hosts the UPV browser and the external access to the files, whereas the render server or render service, they can be multiple, I'll come back to that later, are providing the models, and they can also be in a locked up environment. And in this case, you might optionally need an interactive connectivity establishment server that's actually creating a communication channel between the clients and the render server. So in this place, I would like to actually do a live demo of the new system. But before we have a look at the new system, let's first look at the system that we're using by now. It's our folder browser that has proven to be really good tool to provide access to different models and make them available for downloading, streaming, or also browser-based viewing. So we took this really good concept and took it a step further, and the result looks like this here. So as opposed to the previous folder browser, you can actually see models more prominent with larger pictures, preview pictures that you can set, also metadata, which I'm coming back to in a moment. And what else has changed? Well, this new UPV browser is actually a combination of the folder browser, the browser-based viewing, and the web services as a platform, which you see here, integrates seamlessly workflows, the UPV browser, and the previous folder browser functionalities with some enhanced features. So what does the new folder browser offer? Well, first of all, not only being able to view the models in a tile view, you can also switch between tile view and list view. In the list view, we also have some additional information, like, for example, tags. What is it good for? Actually, when we're searching. So we can now search not only by a model name, for example, demo. So we'll only get models that have demo in its name, but we can also filter, for example, by tags and say, okay, water. Oh, okay, yeah, I got an oil rig. It's placed in water, and we got a water treatment plant. So you see also partial searches through the tags are possible. Interesting thing here is, where do these tags actually come from? Also, when we switch to the tile view, we don't get any results here because we still got a filter active. But you see, easily switch between filters. Where do the tags come from? Well, when I click on a picture of a plant, I actually get a metadata information view. So here I can actually read additional descriptions or tags. And in order to edit these, if I have the according permission, I can just go and edit. Also change the preview image. So I'll do this very quickly and take a wrong picture here and say, no, okay, I want to go back. Basically, this is the standard model picture. And I can also add tags here. For example, add a tag for area 10123. And once I click submit, this metadata is updated. And when I go back here, go to list view, you can actually see area 10123 has been added. So this way I can dynamically add tags to be able to filter models accordingly. Okay, great. So what else do we have here? First of all, we can open models of any size really within seconds. And I would like to demonstrate this with our huge demo. So this demo site that I'm opening, you see, okay, how long did it take? 2 seconds? Is not just a typical site you might, or a typical model you might have. This model is about 1.7 by 1.5 miles large. Or in kilometers, it's 2.7 by 2.4 kilometers. And still, we can easily and well, move through the model and call the attributes, but not only for objects close up, but I can also click on any object far in the background and say focus on it. And within a few seconds, the graphics is updated and the attributes are shown. And just to give you an impression of the overall size of the whole plant, so you see the separate areas here. If I go into top view, you actually get an impression of really what mere size this object has. It's actually 1,000 times our default demo plant. And again, opening up within seconds, and worldwide this is a unique feature that only the UPV in combination with browser-based viewing can offer. So let's go back here. Why does it work this fast? Well, because we're using a preloading technology. What does preloading mean? So instead of opening the model at that moment when the user requests it, in order to save loading times, you can set models that are frequently used to preload. And preloading means that on the render server, this model is loaded and put into idle mode until a user requests to use it. How does this work? Well, let's go to settings for this and to the browser-based viewing models. For each render server, we have an overview here where we can define a model folder search path, the models that it's found under this path, and under preload, we can define how many instances are going to preload. So in this case, for the demo plant, it's preloaded 2 times. This does not mean that when a third user logs in, that he will not get a model, but up to a maximum instance limit, anytime or every time a user logs in to use a preloaded session, this session will preload one more time in the background. So as long as this instance is available, always 2 plants will be preloaded. And this way it speeds up the whole process. So when I said for each render server we have a tab here. Yes, you can have multiple render servers, and you can also have multiple render servers in a redundant setup, meaning having the same model infrastructure. The models are recognized as one, and the UPV web services will do automatic load balancing between those machines. That means even if your hardware, or you're limited by hardware to a certain number of concurrent streams and models, you can basically use a limitless number, almost limitless number of rendering servers to actually extend the capacities dynamically. This also gives you the option, for example, to use a hybrid mode where you have a render server on premise and, for example, another render server for peak usage that you turn on and off as necessary somewhere in the cloud. So what else can we do here? Well, when I go to administration, you see we have user settings, and where as an admin you can activate and deactivate certain features. You have user groups and permissions. So users in user groups can be actually pulled from an external authentication system. So when they log in, for example, Active Directory groups are similar. As long as it supports the OpenID Connect protocol, you can use almost any external authentication service, and it will communicate with the internal identity server and provide the user groups. When we go to permissions, we actually have the option to limit certain models to certain user groups. So, for example, I can add a permission here for the demo plant and say, okay, 3D designers, they have a full read capability. For add a permission here and say, okay, PID designers, they have full read as well. Huge demo will have, for example, only for project managers, full read. And when you click on an object and scroll down, you still have the option to change folder permissions or to utterly delete them. So let's say I want to go here to project managers, delete. And what do these permissions do? When you log in to the UPV browser, you only see the models that you are actually granted access to through these permission settings. Okay, great. So some smaller details here are also that you can add custom links, because we were asked by many customers to integrate a function like that. So for example, some help desk website, or link to an intranet, or to some online forms you might be using in your company. So when I click on it, it opens up in a new tab. To these here, I'll come back in a second. basically, to add these links, all you have to do is go into administration, settings, and you can add links and their name they will be displayed by in the menu. Easily add or remove them or change them. For example, instead of default search, I can enter Google search, and as soon as I submit and go to the links, you see, okay, it has changed to Google search. In the same manner, you can also change the description here, or for example, your internal help desk's email address or phone number. This can all be added through the settings here. But okay, let's come to the interesting point, API. What options do we have for API integration? So we have actually two ways. One is the web API to directly access functions in both directions. And we have the UPV API, also known as deep linking. So you might know the deep linking from the client-based application of UPV, where you can link directly into your model. And we have extended this now to support also the browser-based viewing. And we created a simple selector where the web service's URL is saved, and you can easily switch between links going to the local viewer or links going to the UPV web services. This being said, let's actually try what this looks like when we use this type of linking. Let me actually switch to a different view mode. Here you actually see the link opening up. Let me remove the panel here, and it has switched to D240. Why I actually made the split view is because this way you can better see the direct effect. When I click, for example, on E240, it switches to different vessel here. This doesn't only work with links here, but you can basically place your links in any application like Word, Excel, or whatever, or even on desktop links like I did here. So when I double click on the link on my desktop, you see that it actually switches the objects too. What other options do we have? Let me maximize this again. Is the web API. So we've prepared an example here, again with our demo plant, where we see the demo plant here and the possible API commands here as a testing environment. Let's say, for example, I colorize objects differently in a demo plant, and let's say I want to revert colors to default. So I could use a command from within UPV, but I could also say, okay, clear color, say task equals asterisk, so all objects, and just say run. And instantly you see that the color is removed. Same thing I can actually do for selection, and say, for example, name equals D240, and say run, and you will see it will automatically highlight the object. So I mentioned we have a bidirectional access to the model. This I can show you best with this example, where we've actually integrated the so-called callbacks. This means that any event like clicking on an object or changing a custom attribute or similar actually calls or triggers an action that will be doing either something externally or internal in the model. In this case, we made a simple example. Whenever I click on an object, it will be colorized red and stays red until I click somewhere in empty space. So this is probably simple but very easy to see and grab example how API integration works. So before we continue to the prerequisites, let me also show you a small preview that will also be available with the release. Still under construction, but just to give you an impression where journey is going to. We'll also have an admin dashboard where you will be able to see the currently used licenses and the currently loaded browser-based viewing models, which user started a certain session, and down here you will have a web services and a render services log that you can easily refresh to actually have access to all information directly from the user interface, and also additionally have CPU and RAM, so memory information of the current watchdog here. So with every watchdog or every render server, you will get an extra tab. Well, now the question that I'm being asked quite often: what are the hardware and software requirements for the browser-based viewing? So if we look at this graphics here, the clients can actually be any iOS. All they have to do is have a modern web browser like Chrome, Firefox, Edge. The old Internet Explorer does not work because it doesn't support newer protocols used. So the UPV web services can be a simple machine running either IIS on Windows Server or Apache Engine X on Linux with, for example, 4 cores, 16 gigs of RAM, so nothing special here. The render server, on the other hand, depends highly on the number of models, the size of models, the resolution, but we have an approximate recommendation having like 2 GB of video RAM and about 4 GB of RAM per streamed model, and recommend a minimum of 8 CPU cores. But that's a question that we can also discuss for the case at hand, because no render server is exactly the same as another one. Good. Well, thanks for your time and your attention. Questions we might not have been able to answer during the webinar will be answered subsequently by email. And if you have any further questions, you can contact us for general information support under the shown email addresses, or contact your responsible sales representative for pricing details and quotes.